Good evening, class. Today we're going to be, or this evening we're going to be going over lesson 2-3, and that is on simplifying variable expressions. Okay, now this can be a very straightforward lesson, or it can be one that really could give you trouble. So I really need everybody to really listen in, and you may want to repeat portions of this if you need to go back over some of the examples. Once you get this, it's going to be crystal clear. But getting it, experience has taught me, is kind of sometimes a tricky thing. Okay, so let's talk quickly about what we're talking about. So what we're going to do is we're going to be starting with some algebraic expressions, okay? And so just to refresh your memory, algebraic expressions are going to be made up of parts. So here's an example in pink. 3x minus 2y plus 5x plus 7y minus 17 is an example of an algebraic expression. Now, it's an algebraic expression and not a numeric expression because we have variables. We have x's and we have y's. Both of those letters represent unknown quantities. Okay, so any expression with some numbers, some pluses, minuses, different operations, numbers, constants, and variables is called a algebraic or variable expression. Okay, so let's take a look at what these different parts are. Okay, first of all, we have coefficients. What a coefficient is a number, like this 3 right here, or this -2. And we always include a minus sign in front of a number to make the number negative. And what coefficients are is they're numbers that are with variables. And they actually are multiplied times the variable, and they tell us how many of that variable we have. So the coefficients in this case are 3, -2, 5, and 7, because those are all the numbers that appear in front of variables, or multiplied times variables. And again, notice we don't include the variable itself, just the number that's with the variable. And again, we do include any negative signs. So 3, -2, 5, and 7 are all coefficients in this algebraic expression or variable expression. Okay. Next, we have constants, and constants are the other numbers that appear in the algebraic expression, and they're numbers that appear all by themselves. Again, we're going to include any minus signs in front of a number, and so the constant in this case is just the number -17. Okay, and again, what's the difference between a coefficient and a constant? Now, these can be a little bit tricky to keep straight. They both start with C, and they both refer to numbers. Coefficients are numbers that come with variables. Constants are numbers that are by themselves. Okay, if that wasn't enough, we have one more term, and that is that some of the things in this algebraic expression are similar parts, and we call those like terms. Now, the like terms in this case refer to variables, terms that have the same variable. So in this case, both the 3x, I'm going to put a box around the 3x and a box around the 5x, both refer to x's. So those are like terms. And if you think about an x like an apple, okay, if you have 3 apples and you add 5 apples, it's common sense that you now have 8 apples. Well, it's the same thing with x. If somebody has 3 x's and then you add 5 x's, you have a total of 8 x's. Those are like terms. Now, there's another pair of like terms, and those are going to be the other variable, the y's. Okay, so we also have, and I'll change the symbol here, let's make a black triangle around this -2y. Well, if I have a -2y, and then over here I have a positive 7y, well, let's just think about that for a second. If you had 7 y's and you gave away 2 y's, you would have 5y. Okay, so those are called like terms. Okay, so once again, we have 3 different parts here, or 3 different things going on. Any number in an algebraic expression is either going to be a coefficient or a constant. If it's with a variable, it's a coefficient. If it's by itself, it's a constant. If we have 2 terms, and terms are things that are added and subtracted together. If we have 2 terms that have the exact same variables, like for instance the blue boxes, okay, where we had x's in both of them, or the black triangles where we had y's, those are considered like terms. Now, the 17, the minus 17, is a constant. If there had been another constant, the absence of a variable is also considered a like term. So if we had added in plus 5 to the end of this, then the negative 17 and the 5 would have also been like terms. Okay, let's move on and let's practice this so we can get it straight. Alright, so let's take the algebraic expression 6 plus 2s plus 4s, and let's identify the coefficients, the constants, and the like terms. Alright, so first off, we have the coefficients. Well, the coefficients are the numbers that are in front of or multiplied times the variables. So in this case, we have a 2 that's times an s, and we have a 4 that's times an s. Those would be the coefficients. The constants are any numbers that are by themselves. So in this case, it would be 6. And the like terms are any two terms that have the same variable. So 2s and 4s are like terms, and so we write down 2s, comma, 4s, and those would be like terms. Okay, notice that the like terms are the whole thing, the 2 and the s, and the 4 and the s, whereas the coefficients are just the number part, 2 and 4. Alright, let's continue here. Oops. Let's look at another algebraic expression, 7 minus x plus 3 plus 4x. Okay, and this is a little bit trickier, and we're going to introduce something new. So first, let's look through the numbers, and let's identify whether they're coefficients or constants. Okay, the 7 is by itself, so that would be a constant. The 3 is by itself, so that would also be a constant. The 4 is in front of an x, and so that is a coefficient. And by looking at this quickly, you might think that we're done. But if you look more closely, how many single x's do we have? Okay, between the 7 and the 3, we have this negative x. Well, let's think about this for a second. If I have 4 x's and I take away 1 x, I'm going to end up with 3 x's. So that negative x refers to how many? 1 negative x. And so while we don't usually write 1 times something, there is actually a negative 1 that is multiplied times this x. So even though we don't see a number there, when we see negative x, the coefficient would be negative 1. Okay, and you can see why this can get a little bit tricky. Alright, now if we continue on here, oops, sorry about that, and finally, one more thing on this one. Do we have any like terms? Well, this one is a little bit more interesting because, yes, this one has like terms. It has two constants, the 7 and the 3, so the like terms, 7 and 3 are like terms. Okay. In addition, it also has a negative x and a positive 4x. So the negative x and the positive 4x are also like terms. And again, you have a pair of the pink ones of constants that are like terms, and then you have another pair of x's that are like terms. Okay? Alright, next, we can simplify the expression by what? Well, let's go back to what we were just saying about like terms. When we have like terms, like we have above in the left example, where we have the 2s and the 4s, well, again, if you think about that, if you have 2 s's and you add 4 more s's, you're going to have 6 s's. So, to finish this little expression here, we can simplify the expression by combining like terms. Okay, and if we do that, let's change back to yellow. Let's change back to white. If we take this top one up here, and we bring it down, and we combine the like terms, we already said that 2s and 4s are like terms. So that will give us 6 plus 2s and 4s is another 6 s's. And if we combine like terms on the second one, the 7 plus 3 leaves us with 10, which is a constant, and the negative x plus 4x will leave us with positive 3x's. Again, it might be easier to think of 4x's first, and then take away 1x. Okay? These, at the bottom, are the simplified expressions. So, what do you have to get out of this lesson? Well, you've got to know what constants and coefficients are. You've got to know what like terms are. and you've got to be able to spot them so that you can combine them. That's it. That's the whole lesson. Okay. Now, like I said, this can be a little complicated, so if you need to back up and listen to part of this again, please feel free to do so. If you feel like you're ready, what we're going to do now is we're going to go on and we're just going to do a couple examples together. And rather than have you stop the video and try to do these on your own, just try to do them, try to stay a step ahead of me, but we're just going to walk through these three examples for a moment. Okay? So let's take a look at the first one. If I have to simplify 3b minus b, well, I can notice that these are both like terms, and so if I have 3 of something and I take one of them away, I will end up with 2 of them, so that's 2b's. Okay? Now, for the second one, if I owe somebody 4 m's, okay, let's say m is something like a Mars bar or Milky Way. Okay, if I owe you 4 Milky Ways, and then, for whatever reason, maybe you do a job for me, and I agree to pay you 9 Milky Ways, well, negative 4 is what I already owed you, and then another negative 9 is a total of negative 13 m's, or Milky Ways, or whatever they stand for. Okay? And again, what do? We combine the like terms, and then for negative 4 and negative 9, when we combine those, we're going to use the 3 commandments, so thou shalt not subtract, so we're going to take negative 4 plus negative 9. They're the same sign, so we combine them and get 13, and we keep the sign negative because the larger, or actually in this case, both of them are negative. All right, one more, and then we're going to change things up a little bit. So in the third one, p plus 6p minus 4p. Let's just go from left to right. So if I have a pea, think about an actual just plain old regular garden pea on your plate at lunch today. P plus 6p is a total of 7 p's, and again there's a hidden coefficient in front of the p. So 1 p's plus 6 of them is 7, and 7 minus 4 leaves us with 3p. And that's how we simplify expressions, by combining like terms. Now we can make this a little bit more involved when we have lots of terms. So let's look at these two examples. Okay, the letter D, to go ahead and do that one, we're going to look for any like terms. And I like to go through and just underline like terms. So I see 6y's and I see a negative 7y. All right? If we combine those, 6 minus 7 of something, if you have 6 and you pay 7 away, you end up with negative 1 or just negative y. Okay? Now let's change colors, and we also notice that we have m's. And if I have 4m plus m, that's a total of 5 m's. Okay? And each of these has been simplified by combining the like terms. Now the first three, there was only one variable, okay, and so it was very easy to simplify. This one, we've actually simplified 2 different variables, and we've combined any like terms, and we finished the problem. Now the last one I gave you is going to have a step that you have to do first. So I see x's, I see numbers, but I also see this negative 2 and this parentheses. And so if you think back to yesterday's lesson, we learned about the distributive property, and this negative 2 outside the parentheses is going to get multiplied across. So before I go any further, I'm going to recopy 4x plus 3. When I distribute, negative 2 times 5 is negative 10, and negative 2 times x is negative 2x's. Now I can go through and I can identify like terms. 4x and negative 2x. 4x minus 2x is just 2x. And plus 3 minus 10. Again, that's positive 3 plus a negative 10. They're different signs, so we're going to find the difference, which is 7. And we're going to keep the sign of the larger value, which in this case was the 10. So we get 2x minus 7. Okay? And so this one was an interesting combination of both the distributive law from the previous lesson and what we just learned about combining like terms. Alright, so as we move forward, what I did is I pulled this slide up, and it was just a random piece of art, but if you look at this closely, I want you to take a look at something really interesting. I see like terms on the slide. Okay, take a look at this button. All right, do you see any other buttons that kind of match that? Well, there's one here, and there's one here, and I would consider those like terms because they're the same basic picture. So you could put those 3 together. Okay, so look quickly. Do you see any other like terms? And they might be slightly different sizes, but I think if you look closely, you'll notice that this kind of brown kiwi looking thing looks an awful lot like a slightly smaller version of this one, and it lines up and it matches up with that one. Okay, by the same token, I think you can see that was probably a bad color. Let's change to a nice bright yellow here. Okay, this one right here that I just put an X on looks like it matches up with this one, and it matches up with this one. Okay. In fact, for most of these shapes, it looks like I can find 3 copies. Here's another one right here. This kind of orange-looking one matches up with this one, matches up with the little one up here. Okay, and so on. And I think you can see that most of these shapes that we see look like they happen maybe partially off the screen, but it looks like we can see pieces of about 3 of them, okay, with slight variations. So again, this kind of actually fits in with the whole like term theme. You're going to be practicing this in class tomorrow, and then following this lesson, the remainder of this week, you're going to be reviewing Chapter 1 so that you can get ready for both Mr. Hurst and myself to review on Monday and start getting everybody ready for those Chapter 1 tests that we have coming up. Okay, so thank you for listening, even though it's got a little long. And again, if you're having any trouble with this might be a video you might want to go back and rewatch. Okay, and we will continue practicing this in the days and classes ahead. All right, good night, everybody. See you soon.